Hello, Team Basecamp. Welcome to this toolbox on power, pedaling, and gearing. Let's start out with some deep science. How do you apply force when you pedal? And here we have a right foot and a right or a drive side, crank side, right? So here's how we apply force. We pedal in a circle. Ta-da! What heck of a toolbox, huh? But let's go a little deeper, right? We're always looking at things like this that are how we pedal in this circle. And we think about the application of force. One of the ways we can think about it is in phases. This is our power phase downstroke. This is our pullback. This is our upstroke. This is a very important setup phase as we prepare for the power phase. Okay, probably still everybody gets that pretty well. But how do we apply force when we're doing that? It actually is a little better to think about this as a force wave. So as we're going in the circle and we're pushing on the pedal, because remember, a watt is how hard we're pedaling multiplied by how fast we're pedaling. But if we just measure the hard part, we're actually making a force wave. Here's the right foot going around in circles. This first one, the dark line, that's what's happening. This is force in Newton meters, so higher is more force. You can see it peaks and drops. And if you're actually looking in the background at the light gray, that's the left foot. It drops and peaks in opposition, right? Because your crank makes you do that. When we look a little deeper at this, we have this idea we're actually creating a power wave peak. So if we think about what's happening here, we're pedaling in a circle. And we have this power phase when we're pushing very hard. And we can see that this power phase somewhere in here is this peak power element. And then as we go around the backside, we actually have the lowest force element, actually can be negative force. Notice that line goes below zero. Now, the height of this peak and the width of this peak are highly relevant to how you make power against resistance. So when you're riding your bike and you think about your bike as a system, you have kinetic energy in the system. And basically what kinetic energy, it's energy, here I'll read the definition. Kinetic energy is the energy in an object because it has motion. So your bike moving forward, as you're pedaling and moving the bike forward, you're building kinetic energy into the system. This kinetic energy has a very big impact on how you pedal. And it's easier to understand kinetic energy and its impacts by taking a look at this little diagram. So my fancy artwork here, huh? So in this little diagram, when you're rolling down a flat on your bike, let's say you're doing 200 watts on a flat, and that's generating 25 miles an hour, right? So you're cruising along 200 watts, you're on a flat, 25 miles an hour. But if you went uphill at the same 200 watts, up a steep hill, this I said 7-8% grade, pick a number, you might be going significantly slower, right? Let's call that 5 miles an hour. Now the watts are the same, but something's different, right? And here's how you can think about something different. If you're rolling down the flats at 200 watts at 25 miles an hour and you stop pedaling, what happens to your bike? Think about it for a second. What happens? You coast, zoom, and you can coast for a while, right? Because at 25 miles an hour, you have a lot of kinetic energy built into the system. So you can spend it down by coasting. Now you're going up a steep hill, 7% plus at 200 watts, only going 5 miles an hour. What happens when you stop and coast? The bike goes about 2 feet and you fall over because you don't have as much kinetic energy in the system because the bike is going significantly slower. Now you understand kinetic energy in the system. But one step deeper in this toolbox, that impacts how you pedal, how your how you apply force, how you recruit muscles, and what happens. So let's look at how you pedal on the flat, same 200 watts, and on a climb. When you're pedaling on the flat, your power phase narrows. You can see I've narrowed down, and who knows, I'm not the greatest at the icons, right? But your power phase becomes much narrower. You're punch pedaling. You're maintaining speed because the kinetic energy in the system is making you go forward. So you don't need to be as complete in your pedaling stroke. And your body's very efficient. It's going to reduce the energy and the recruitment of muscle as you can. So you're punching. You've ever heard that term, a roller or a puncher? That's why they talk about it. They're very quad dominant athletes who tend to be quad dominant and a little more fast twitch can be very good punchers on the flats. They just do that little punchy pedal stroke and it keeps them going high speed, high kinetic energy. The kinetic energy is maintaining here. They're not making force, they're making all their force here. The bike is almost coasting here. Not true because the other foot's coming down. Now, when you go uphill, the power phase actually expands. Again, because the bike will fall over. You don't have any real kinetic energy, depends how fast you're going and how steep. But you have a limited amount of kinetic energy. And so if you don't pedal a more of the circle more throughout the power phase, the bike gets very herky-jerky, right? And you actually can wobble and fall over if it gets going to. So watch somebody going up a 20% hill and they can't maintain speed, they fall over. Kinetic energy, they can't resist the resistance, and they fall behind the resistance. There's no kinetic energy helping them. All right, so Tim, why say all this? I get it, sorta, I feel it, I'm interested in learning more. Along comes modern trainers, and modern trainers are all built on a heavy flywheel system, and they're all this way. I picked a Wahoo because it's a nice clean picture. Pick whatever modern trainer. They average a flywheel, the spinning heavy thing in here, or they mimic it like the Garmin Tax. They mimic, and these flywheels are anywhere between 17 and 20 pounds. There might be even some heavier. And the reason they're using, remember old trainers had little magnet, and they were little fluid trainers and magnet trainers. Even the old CompuTrainers only had little flywheel drums, right? They weren't that heavy. CompuTrainer was like 7 pounds. We realized that if we put a big, heavy spinning object in there and it builds up a lot of kinetic energy, it feels more road-like. It feels more natural, better road feel. So people liked riding those trainers better. Oh, this feels like the road. It's great. But the reality is it feels like the road when you're riding flats. And even if you work against some resistance and stuff like that, once that flywheel gets up there and spinning, the reality is there's still kinetic energy in the system. That flywheel, if you're going 10 miles at 200 watts up to Zwift versus 30 miles on Tempest, I forget whichever, Tempest Fusion, whatever it is on the flat, the flywheel is still spinning very fast in there. So it's not truly representative of the real impact of kinetic energy. Then when you go outside and you're pedaling in the real world and you have some climbs and stuff like that, your power doesn't transfer well. So the reality is that big, heavy flywheel spinning at a very fast speed has got a bunch of kinetic energy in it. Now, kinetic energy in the flywheel moving fast doesn't necessarily mean your avatar is moving fast or you're going a bunch of miles or kilometers per hour. It just means the flywheel is moving fast. That high flywheel speed mimics the demand just like we do on rolling flats at high speed. That's why you enjoy at times being on the trainer. It feels good. You're just punching. You're not doing as much work, but what's happening, that's shortening your neuromuscular signal. And if you spend a lot of time on the trainer, particularly in erg mode or even in incline mode with the resistance all the way down, and you're just using a bigger gear, which most of us do because it feels more natural. So you're usually using a harder to pedal gear, the flywheel's humming along and spinning nicely, and you're just learning to punch. What's happening is you're shortening your power phase. You're just teaching the neuromuscular coordination to be more punchy. And then when you go outside in the spring and you start climbing, you struggle with climbs for a couple of weeks. It's not that your fitness is bad. It's your power phase is shorter, your neuromuscular coordination, and you could kind of call that strength or lesser. So over the next 3 months, we're going to be using your ability to select gears. Yes, even in erg mode, even in incline mode, selecting gears has impact because it will impact that flywheel speed. So you're going to begin to see selecting a gear. It's actually selecting your flywheel speed. I'm going to translate it to gears in one slide. The direction is there. You're going to see a varying. Sometimes we want that high speed. We want that punch. We want to work on the ability to be fast and flats and keep up on the group rides and really go faster. Sometimes we want to mimic more climbing. We want to slow that flywheel down, force us to pedal a more complete power phase. This will better prepare us for outdoor riding. Now, I'll tell you what, about 70% of you, when you do the experiment with this, you're going to feel it. It's going to actually potentially even surprise you how much you feel it. So be prepared. It's going to bring some extra fatigue in the first couple of workouts you do. If you feel it and like, wow, I tried the big gears versus the harder to pedal gears versus the easier pedal gears, and the easier pedal gears felt so much harder, that's telling you something. It's telling you you've begun to become you're addicted to the kinetic energy. You need your kinetic energy fix, right? And we need to use our gears to change the flywheel speed, not your power. We're just talking about changing how fast that flywheel. So we're removing kinetic energy or putting kinetic energy into the system to impact this. Some days, bigger gears, we're targeting that shorter, more powerful, punchy. Lower, easier pedal to gears, we want to spread that power phase out. By doing both, we'll better prepare you. Now, just to make sure we understand the language of this, when we're talking about making your flywheel a higher speed, we want you to use harder to pedal gears. So the big ring up front, you might only have one ring, so you don't have this option, but the big ring up front, the biggest one you have, in a small cassette selection. This in today's, you might be 48, 10, 48, 11, 12, that type of combo. That is going to produce, because it's a bigger gear, it's used for when your bike is going faster, it will spin your flywheel faster. That is high speed flywheel. Low speed, you want to use your easier to pedal gears, your climbing kind of gears, right? And that's, you want your front a little smaller. So maybe a 34, 32, depends on single, front setups could be different. And you want to use your biggest gear in the back. And I'm not even going to guess at that, 50, 48, 38, 28, whatever it is. Just mimic your best climbing gear in the back. That will slow down the speed of that flywheel and make it feel a little bit more like climbing. Now, I will tell you right now, there will be plenty of questions on this about, well, changing my gear doesn't make my avatar go faster or not faster. Again, I will tell you, you're going to put out the same power. You just have more or less kinetic energy in the system, slightly changing the way you pedal by impacting your power phase. Hope that helps. Thanks, everybody.